Hi, welcome to Algebra 2 Common Core. Today we're going to look at quadratic inequalities. So solving quadratics that have inequalities rather than equations. So let's look at exercise number 1, where we're going to get a feel for how we tell whether a number is a solution for a quadratic inequality. In part A, it says, let's determine if each of the following is a solution to the given inequality. Show work to justify your response. So for our first inequality, I've got x squared minus 3x minus 10 is greater than 0. I want to know if x equals 4 satisfies this inequality. So we are just going to substitute the 4 in for the x and get 4 squared minus 3 times 4 minus 10. And we want to know, is this greater than 0? So of course we're going to go ahead and do the arithmetic. So I've got 16 minus 12 minus 10. Is that greater than 0? When I add all those numbers together on the left side, I get negative 6 is greater than 0. And of course, I see that that is a false statement. So that tells me that no, x equals 4 is not a solution. So that's all that's involved in determining if a number is a solution for a quadratic inequality. For part B, let's substitute 2. So I'm going to say 2 times 2 squared plus 13 times 2 minus 7. And we want to know, is that greater than or equal to 0? So again, let's follow the order of operations. So I've got 2 times 4 plus 13 times 2 is 26, minus 7, is that greater than or equal to 0? Adding everything together, I get 27 is greater than or equal to 0. And I see that yes, that's a true statement. So if that's true, that tells me that x equals 2 is a solution. Please pause the video and try part C on your own and then come back and compare with my answer. When substituting negative 3 in for x, I found that I ended up with the inequality 0 is less than 0. Of course, that's a false statement, so that tells me that negative 3 is not a solution for this inequality. So as you can see, there are going to be solutions that work and then other numbers that don't work and are not part of the solution. So our goal today is to try to figure out what numbers work for any given inequality. So in exercise number 2, we're going to go through a step-by-step solution for the next quadratic inequality. I have the quadratic inequality x squared plus 2x minus 3 is less than 0. So we're going to start by solving the quadratic equation, x squared plus 2x minus 3, and I'm changing this to equals 0. So that's always going to be our first step. Go back to the equation. This is a trinomial that is factorable, so I'm going to say the factors are x plus 3 times x minus 1. Setting each factor equal to 0, I have the two solutions, the two zeros for this quadratic are negative 3 and positive 1. Now we're going to need our calculator for part B, so if you don't have it, please pause the video and go ahead and find it. I'm going to enter this quadratic equation into my graphing calculator in Y1. And let's make a table of values going from negative 5 to 3. So take a minute and enter that in your calculator and fill in the table. So I've completed the table using my graphing calculator, and I of course see that I also can find the zeros using my table. Negative 3 and 1 are the zeros of this quadratic equation. Now in part C, the zeros can't be part of the solution because my original inequality was just a less than sign. So we know that 0 is not less than 0, so therefore I don't want to use -3 or 1 as part of my solution. But instead, when I look at my table, I see that all of the values that come between -3 and 1 have negative answers. Less than 0, of course, means that I am looking for negative answers when I substitute the values in for x. So this tells me then that my solution is going to be the set of all x such that x is bigger than -3 but smaller than 1. And again, we're not including those endpoints. On a number line, it would look like this. Let's go from -3 to 1. We are not going to include the endpoints, so I'm putting open circles at both of those spots. But all of the numbers in between do solve my quadratic inequality. As you could see from that first example, the most important thing for solving a quadratic inequality is to first find the zeros. And then what we're going to do is test points that come between the zeros. And we'll also look at values outside of the zeros. So if I look at the inequality for exercise number 3, x squared minus 4 is greater than 0. I'm going to go back and make this an equation, so x squared minus 4 equals 0. I can do this by factoring or by moving the 4 to the other side. I think I'll stick with factoring, so x plus 2 times x minus 2 equals 0. So that tells me that my two zeros are going to be x equals -2 and x equals +2. So these numbers become the endpoints of my intervals. Go ahead and make a number line, and let's put those two numbers on my number line. Now when I look back at my inequality, I see that I want greater than 0 this time. So greater than 0, of course, means that I want all the solutions that give me positive answers. Notice that greater than 0 does not include the endpoints, so that tells me that I'm going to put an open circle at the -2 and the +2. Now what we're going to do is try a number, test a number that falls in each interval. We're going to test it back in my original inequality and see if the inequality is true. So for example, let's come back here before -2 and let's test -3. So when I substitute -3 into my inequality, -3 squared minus 4, is that greater than 0? And I see that yes, that is true. So I want to go ahead and shade that section of my graph. Let's test for a number between -2 and 2, so for example 0. So 0 squared minus 4, is that greater than 0? And I say no, that doesn't work, that's false, so I'm not going to shade that part. Let's try a number after 2, like +3. So 3 squared minus 4, is that greater than 0? And the answer is yes, it is true. So that tells me that I want to shade this end. So now which of the possible choices are represented in my solution set? I see that it should be choice number 3, where x is all numbers bigger than 2, or less than -2. So we're going to get some practice in solving quadratic inequalities today. So let's try exercise number 4. I've got the quadratic inequality x squared minus 5x minus 36 is less than or equal to 0. So my first step, of course, is to solve the quadratic for the zeros. X squared minus 5x minus 36 equals 0. So that means that I want to factor this, because it's a trinomial that is factorable. My factors have to add to -5, but multiply to -36. So I'm going to say x times x, And I think the combination that works is a -9 and a +4. So let's go ahead and set each of those factors equal to 0. So I get x equals 9 as one of my zeros, and x equals -4 as the other one. I like to go ahead and put it right on the number line so that then I can use the number line to do my testing. So I'm going to put the -4 down here and the 9 down here. Now, when we go back to our original inequality, we see that this inequality was just a, oh, wait a minute, it was a less than or equal sign. I think I'm kind of missing that equals because of the m that I wrote in there. So it should be less than or equal to. So less than or equal to means that I want negative solutions, or I want the solutions that are equal to 0. So my endpoints will be included, so I'm going to fill in the circles at -4 and 9. Now we want to pick test points in each interval and test them in our inequality. Sometimes it's easier to test them in the factored form of the inequality. So for example, if I am testing -5, when I try -5 for x, -5 minus 9 is a negative answer. -5 plus 4 is also a negative answer. Negative times negative gives me a positive answer. I wanted negative, so I'm not going to color that section. Let's try a number between -4 and 9. So let's, for example, try 0. Plug 0 into this factor. That gives me -9. 0 substituted in here gives me +4. So negative times positive is a negative solution. So I'm going to color in between. Shade the number line, all the numbers between -4 and 9. Let's go ahead and try a number after 9. 10 works nicely. So when I substitute 10 into this factor, that's positive. 10 into this factor, 10 plus 4 is positive as well. So positive times positive gives me a positive solution, so it doesn't fit the requirement of being negative. So therefore, my solution is just all the numbers between -4 and 9. Now you'll notice that the directions say to give this answer in set builder notation. So I'm going to say x such that x is greater than or equal to -4 and less than or equal to +9. In other words, x is any value between -4 and 9, including the endpoints because I've got equals as part of my inequalities. Let's try part B together. I see that I'm trying to factor. Actually, I want to first of all make this into an equation where it's set equal to 0 to find the zeros. So we are going to get 5x squared plus 28x minus 12 equals 0. So I've got to think about what factors I'm going to use here. When I see that I've got a number other than 1 in front of my x squared, that tells me let's try the box method. Or grouping if you like grouping. So I'm putting a 5x squared here. I'm putting a -12 here. I want to add to get the middle coefficient, 28. I want to multiply to get that product, -60. Let's think here. Product of -60, I'm thinking maybe 30 and -2. Don't forget to put x's with each of those when we put them in our table. So 30x and -2x. In the top row, I'm going to factor out a 5x. In the bottom row, let's factor out a -2. In the first column, I've got an x common to both. And in the second column, I've got a 6 common to both. So my factors should be 5x minus 2 times x plus x. Setting those equal to 0, I see that my zeros are going to be 5x minus 2 equals 0. So 5x is equal to 2, and x is equal to 2/5. The other factor, x plus 6 equals 0, so I get x is equal to -6. Go back and look at that factoring if you need some extra time with that. So on my number line, I've got a -6 back here and a 2/5 over here. Now, since my inequality did not include an equal sign, that tells me put an open circle at both of those zeros. Now, let's test a number in each section, but again, as I test, I'm going to test in my factors. So let's try -7. 5 times -7 minus 2, that's negative. -7 plus 6 is also negative. Negative times negative is positive. And yes, I do want positive because greater than 0 means positive. So let's shade in that section. Let's try a number between -6 and 2/5. How about 0? Plug it into your first factor. So 5 times 0 minus 2 is negative. 0 plus 6 is positive. Negative times positive is a negative answer, and that doesn't satisfy this inequality. Let's try a number bigger than 2/5. So down here, how about the number 1? 5 times 1 minus 2 is positive. 1 plus 6 is positive. So that gives me a positive product, so I'm going to shade that end as well. In in set builder notation, we want x such that x is less than -6 or x is greater than 2/5. So we want one end or the other, but not the numbers in between. For the next example, we're going to have to write our quadratic in standard form before we can find the zeros. So the 2x squared isn't going to change, but we're going to need to subtract 10x from both sides of the equation. So that gives us -14x. If I add 8 to both sides, I don't have any constants left. So I want to keep the greater than or equal to 0. So that's the quadratic inequality that we're solving. Now this one isn't a trinomial, so when I set my polynomial equal to 0, I'm going to do a different kind of factoring. This one looks like it's going to be a GCF, so factor out a 2x, and I'm left with x minus 7 equals 0. So that gives me the two zeros, x equals 0 and x equals 7. Making my number line, I'm going to include 0 and 7. And because the inequality included an equals, I'm going to fill in the circles at 0 and at 7. Let's try a number in each interval. So let's go back to a -1 back here. 2 times -1 is negative. -1 minus 7 is negative. Negative times negative is positive. And that's in fact what I want to have because I want greater than or equal to 0. So I am going to color this interval. Try a number between 0 and 7. How about the number 1? 2 times 1 is positive. 1 minus 7 is negative. Positive times negative gives me a negative result, and that's not what I'm looking for. And let's try a number in the last interval. How about the number 8? 2 times 8 is positive. 8 minus 7 is positive. So positive times positive is positive, so I'm going to shade that section. In set builder notation, the solution would be x such that x is less than or equal to 0. Remember, we're going to put an or again in this situation because we want one end or the other. On the right side, x is greater than or equal to 7. Now I'd like you to pause the video and try part D on your own and then come back and check with my solution. So compare your work with mine. When I put this in standard form, I ended up with a polynomial that was the difference of two squares. So I factored that as x plus 5 times x minus 5. Setting it equal to 0, I get the two zeros, negative 5 and positive 5. Put those on my number line, but don't fill in the circles at those numbers because I see that I don't have n equals as part of my inequality. When I tested numbers in each interval, the only interval that worked was between negative 5 and 5. So I shaded that section and then wrote the compound inequality in set builder notation. Exercise number 5 gives us a number line graph and asks us to figure out which is the quadratic inequality that goes with it. Well, we could try out each of the 4 choices and find the zeros and then decide on the shading. But I'm going to approach this in a little bit different way. I'm going to go the other direction. When I look at my number line, I see that negative 4 is one of the zeros and positive 2 is the other zero. You'll notice that negative 4 and positive 2 are both shaded in, so that tells me that I'm going to have an equals as part of my inequality. Automatically, then, I'm going to eliminate both choices 1 and 2. Now, if negative 4 is a 0, that would come from the factor x plus 4. If 2 is a 0, that would come from the factor x minus 2. So if I set that equal to 0, I would have x squared, multiplying this out by double distribution, plus 4x minus 2x minus 8. Right now it's an equation, so I've got x squared plus 2x minus 8. Now you'll notice that it's shaded in between, and then when I look back at the examples that I've done previously, shading between those two numbers is generally the result of having a less than sign. So that tells me that this is going to be a less than or equal to because I've got to include my endpoints. If you look carefully, you see that yes, choice number 4 matches up with that one. And again, you could try some numbers between negative 4 and 2, like 0, to make sure that it is a solution. So 0 squared plus 2 times 0 minus 8, is that less than or equal to 0? And the answer is yes, because negative 8 is less than or equal to 0. So that does check. That is a true inequality. Let's finish with exercise number 6, where we have a quadratic inequality representing a projectile. So a projectile is fired from the ground such that its height h is given as a function of time t. We want to find the time interval when the projectile is more than 64 feet above the ground. So let's write this as an inequality. We want to say negative 16t squared plus 80t has to be greater than, it says just more than, so I'm not going to put the equals, more than 64. Let's start by putting this quadratic in standard form and setting it equal to 0. So negative 16t squared plus 80t minus 64 equals 0. I can factor a GCF out of this, so I'm going to take a negative 16 out. And I'll be left with t squared minus 5t plus 4 equals 0. So factoring that trinomial, that gives me t minus 4 times t minus 1. Now you'll recall that when we have a constant in front of my factors, the constant is not going to be able to equal 0, so I'm not going to use that as one of my possibilities. Instead, just use the factors that have t, so I get t equals 4 and t equals 1. Let's make our number line and do some test points. So we've got a 1, we've got a 4, We see that we just had a greater than sign, so I'm going to put open circles at 1 and at 4, and I'm going to test points. Remember that T stands for time, so that means that I don't want to go anything in the negatives for my time. But I could put 0 in. So when I put 0 into I would probably put it in the factored form. Negative 16 is negative. 0 minus 4 is negative. 0 minus 1 is negative. So negative times negative times negative gives me a negative answer. That's not going to be greater than 0, so I'm not going to shade that section. Picking a number between 1 and 4, let's try 2. Plugging in here, I see, well, I've got a negative 16. That doesn't change because it's a constant. 2 minus 4 is negative. 2 minus 1 is positive. So a negative times a positive gives me a positive answer. So I'm going to shade this section. Try the number 5. So negative 16 times 5 minus 4, which is positive. 5 minus 1, which is positive. That gives me a negative solution, so that's not what I'm looking for. Therefore, I know that the time interval that works here is going to be when t is greater than 1, but less than 4. Now you could check that in your graphing calculator by entering your quadratic into the calculator for y1. Look at your table of values and look at all the numbers that are between 1 and 4. Are you seeing that those values all give you a positive answer? So that's definitely going to be the section that I want to shade. We've done a lot of work on quadratic inequalities today, so make sure you understand the steps for solving those inequalities, and we'll look at some more examples in class. Thank you. Have a great night.